Good afternoon, everybody. It's a challenge to speak of this climate change conscious urban neighborhood design in 20 minutes. So instead, I think I have to revise the title, just say it's about focus on simulation. So it's a theory of simulation. Well, let's see if we can find any theory in that. But I will just report to you very honestly what we have been developing over the years in Sheffield on this topic. So that the outline of my talk is, the first section is I will start with compositions. Where do we start? Where do I believe there is some truth in it, there is some value in it. The second section will be two diagrams. It's a summary of the methodology we have developed over the years, and also set a response to the proposition that I put forward in section A. The next section is presentation of a few experiments that has been conducted and planned so far. And finally, I will just round it out with some of my personal reflections and some further questions. Okay, propositions. If you know, on 27th of September this year, the UN Intergovernmental Climate Change Panel published the fifth assessment report. And this is the first sort of strap line come out of this assessment. They're doing every 6 years, this panel do assessment reports. And that's a global effort, hundreds of scientists working together to look at the current situation. So the first one is 95% certainty. Humans are the dominant cause of global warming since the 1950s. So that's published 27th September. The assessment will go up in the future, no doubt. Second one is the global surface temperature increase by the end of the 21st century. It's likely. Likely means, in their report, they have very precise definition of what we mean by likely, or they have a grading of this terminology, like the probability. So it's very likely, it's likely, not very likely, it's likely to exceed 1.5 centigrade relative to the period of 1850 to 1900, this period, in comparison to the previous one. And it's likely to exceed 2.0 degrees C for many scenarios. So projections according to several scenarios. Scenarios built upon their kind of economic model, how the world is going to react to the climate change, the data, the model has been produced to do that projections. If people decide to do certain things, that's speaking to a different scenario. But for many scenarios, it's saying it's likely to exceed 2 degrees. So this is on a global scale. 1.5 increase, that's enormous amount of energy that been trapped by greenhouse gas. Now you know about the recent Philippine typhoon. Is so destructive, and I think in many ways, nature has its way to vent this stress. The energy has been trapped in the atmosphere. It has to go somewhere. We spend energy to put up buildings. The energy is in there, bonded together. The typhoon comes around, then take everything apart, so energy dissipates. The third point is about climate change poses environmental, societal, economical, health and well-being challenges to local resilience that is unseen before. Next one. A climate change conscious urban neighborhood design is more likely for its both outdoor and indoor spaces to perform better under climate change scenario. This is my proposition, it's not from the international government's panel. And the next one is, what do we mean by to be conscious? To be conscious is to be able to ask questions. And we are all in the same resilience boat. So asking questions, asking climate change questions you as designers, architects, need to be able to ask questions. But when you go out in practice, in a few years' time, maybe your clients, your stakeholders, your users will ask your proposals. How will your proposal perform in the climate change scenario in 10 years, in 20 years? So the next one is, this one I'm hoping. We now have the computer models, the global scenario model, how the CO2 emission, etc., is going to give us the kind of weather we're going to live in. We have softwares, we have weather data sets to conduct both outdoor and indoor environmental simulation. And because this capability, this data, this model, we're able to do some simulation at the urban neighborhood level. So I'm going to go this very concisely this afternoon. Okay. Right, okay. So it's about digital modeling and simulation for climate change conscious urban neighborhood design. Could it make contribution, even a small noticeable contribution to building local resilience? Okay. Right, just a few news. If you notice news, we had a very busy weather news this year. On the, you can see that 10th of May, 2013 on top there. It's the first time that our carbon, next one, sorry, can you go back to this one? It's the first time the carbon dioxide CO2 per symbolical mark is 400 ppm. This 400 ppm means 400 molecules of CO2 for every 1 million molecules in the air. And this is measured in the US government agency lab in Hawaii on a volcanical site. This 400 ppm was 3 to 5. The last time the CO2 was regularly above this level was about 2 to 5 million years ago. So that's a very dramatic change in terms of what's going on in our air. Next one. And then moving on to June. And with this, we have the coldest April recorded in 100 years. We have the wettest June again. So it's a very busy year indeed. Every now and then we have these headlines in the UK as well and abroad. So there's a meeting called to discuss what's going on since we have a very chilly winter of 2010-11 and a very long and wet summer of 2012, etc., etc. But the meteorology thinking, this is not cannot be easily attributed to climate change. It's much more complex, and there is this terminology called climate variability. The variable, climate variable, and climate change are two different things. Okay, well, next one. In September, we have this. We have a lovely warm late summer, but this one it gets so hot. The temperature reaches 91.3 because of the building. The curved walkie-talkie building and finished. The curved curtain becomes a lens that converge the sunlight, and then reflect that energy to a potentially a very narrow spot, and the temperature can reach 91.3 degrees, and that can melt a jacket, a car, just parked unfortunately on that spot. So that's definitely changing, very busy, and we don't know what's going to happen next year. But hopefully we'll be not as busy as this year. The next one, please. So in the past 3 years, we have looked into a way of how to bring our study, our environmental simulation and modeling on the outdoor, but also we have tools to study a building in those simulations. So the first diagram is very simple. On one hand, it's about developing urban neighborhood design. Please. And it covers multiple domains of expertise and ideas on working on buildings, landscapes, open spaces, even biodiversity. That is the domain we're talking about as an urban neighborhood design. And through simulations, and in particular, we want to know what you propose in terms of your environmental and energy performance and climate change scenarios. The UK CP09 is the latest UK Met Office projections of future climate change scenario in 2020, 2050, and 2080. These are the data will be useful in terms of we want to know how our neighborhood or buildings will perform under these simulations. Okay, so according to this concept, then we start looking for tools. As users of tools, we are not developing completely new systems in simulation because they require many, many years of research and development to develop these tools. The first software is called AndyNet. It's made by a team based in Mainz, in Germany. It's a free software, but it's not open source. It's called AndyNet. The AndyNet allows you to carry out urban microclimate simulations, including buildings, including plants, including services, everything that you can describe the essential outdoor elements of an urban neighborhood. Then through this this sort of workflow, we can all work down to on the right-hand side in the whole building simulations. You use, for example, Ecotech, or some of you heard about this. Ecotech. The problem with working with Ecotech or any other whole building simulation is that it only looking the building itself. It does not know about what this building is situated in, what kind of immediate surrounding. So our goal is to see, can we bring outdoor and indoor simulation together? Because we now have AndyNet who knows outdoor, but he knows nothing about indoor. We have Energy Plus, we have Ecotech, we have Design. It knows about the interior, indoor space, but it knows nothing about the outside. So the question is, how do we bring them together? Okay. So we have, in the past 3 years, we have done a few experiments. This entirely is computer-based simulations. The first one is the story starting in Egypt, in New Cairo. Proposed new residential neighborhood. We took this as a case study. It's unbuilt, it's just on the drawing board yet. And Shawan was working with me at that time, and he completed this project in this year and returned to Cairo. Okay, the next one. And we worked with a group of master PhD students in 2012 to use a site in our campus. The idea is to apply what we learned from the New Cairo cases and then apply this to the Sheffield campus. And the next one is Chu Yuan-yi. Chu Yuan is from South Korea. He's currently a PhD student in Sheffield. And he's interested in applying this methodology and try to test it out in cities in South Korea. Okay. The next one. And this year I'm part of the Interactive Urban Skin Studio working with Aiden and Zhongxian. I believe 5 or 6 year 5 students will be working in this studio. And the idea is that we're going to take in the newest Sheffield campus master plan and put into this climate change simulation to see how it will perform and as a starting point. Last but not least, yes, is Julie is going to, next year we're looking into, we already decided which cities in South Korea, the neighborhoods will be selected to conduct simulations. Okay. Very quickly. So that's Ansh is finishing his PhD, and now we're back to Cairo, continue his teaching and research there. Okay. Next one. So that's the neighborhood design New Cairo site. Is to the east of the old city. The old city is very compact, and it seems the government then the idea was to choose a rather vacant site in the desert and creating a new town. And so Ansh took this as an example and start applying this methodology to it and to see how the tools will work together, like doing outdoor and indoor simulation together. So I wouldn't be able to go through this in great details, right? But basically, you describe the neighborhood to the software, and in terms of the building, in terms of plants, the service, etc., etc. But one thing you can do is that you plant these what is called receptors. You can see this as a virtual weather stations, and you plant it around your buildings. And this virtual weather station will be able to collect the essential weather data as simulated by the software. And that becomes the input of your building simulations. So you're not relying on a weather station that's about 30 miles away. If you're using Ecotech, and if you say the building's in Sheffield, most likely that weather station is coming from Finland. The Finland is about 50 miles away from so this is about bringing the weather data more closely to our best knowledge that seems to be reflecting what the immediate surroundings that buildings will face. We move on, please. So and this is our software called, it's developed by the UK Climate Change Program. This software is basically a spreadsheet that can take existing present weather data, apply the climate change scenario, and give you the projected weather data in 2020, 2050, 2080. And using that as basis to do your building simulation. But in our case, we apply this simulation back to ambient and let ambient to run simulation and tell us what is that neighborhood is going to feel like in terms of temperature, in terms of relative humidity, in terms of all the other very important climatic conditions. Okay. Right, doing this. Okay, I'm not going to through this. So this is the kind of results we can get from ambient simulations in terms of 2020, present day, 2050, 2080, all the major climatic predictions that we can get out very quickly. And then we apply this neighborhood where the data goes into an individual building simulation and to see how, in this case, Ecotech predicted internal air temperature might change through these decades. Okay, you can see the weather, you can see the colors changing. One thing we find interesting is this. If you're using a default weather data that Ecotech sort of asks you to do, and then compare that, the weather data we generate through ambient simulations, it does show the difference. Across all the case studies we do, that if we look, taking into account a more local, urban neighborhood weather data, Ecotech is to predict a higher temperature in the buildings. I think here's a question: is that a kind of urban heat islands because of the building surroundings, and that makes a difference. But we have to carry our own case study simulation to verify that. Okay. Then we apply this to Sheffield campus. We choose 4 buildings, Jessup West, the music departments and ICOS and the region court in 2012 simulations, and the students group to look into this. So we simulate the whole site, and then again apply the same principle. The neighborhood weather data will be the input of the indoor simulation. There you go. Right, that is the output from the whole the campus neighborhood projections from 2012 to 2015 in terms of air temperature, radiant temperature, relative humidity, wind speed. Okay. That's wind speed and wind directions. Like finish up. Can we go all the way to the final one? Well, I won't be able to tell that because this is the results what will be reflected inside in the individual buildings. Right. Okay. All the way to the final one is just visualizations. Okay. The final one is very briefly that simulation model like Animate can be used to contextualize your whole building simulations and taking into account simulated urban microclimates of present day. And if you use these weather projection software, you can do that for future climate change scenario simulations. Second one is contextualized building simulation predict higher indoor air temperature compared with simulation with default city-based, that's often remote, very likely to remote from the site you are working on. Third point is the possible effects of urban heat island may be captured by Animate in generating neighborhood-specific weather data through this deployment of receptor, these are ideal virtual weather stations. Okay, but we're still working on several areas. For example, that how do we know the simulation is accurate, is that trustworthy? Without carry out field measurements to validate that is a question of how, as a software user and a simulation engine user, how do you know that the output you can trust? Second one is we do need a holistic visual languages to communicate when outdoor and indoor communicate. As I said, these two different softwares, they have a different way of communicating the performance simulations. Even if we can piece them together. So this is one area we need to work on. And finally, 3 and 4, we found many gaps to perform this digital workflow. There are so many gaps. There are so many tedious manual-based work we need to go through. So there's a gap to do finally. And we need to be able to achieve this design in more interactive fashions. We need a more computing power because each simulation takes about 10 to 15 hours to complete the cycle. Okay, conclude.
Thank you, Chengzhi.